This is a fairly simple problem to solve, and I would expect that you will encounter this problem in your beginning coding days, because all you need to do is find out a way to arrive at the solution just by doing a single iteration of the array. So let's see how we can do it. Hello friends, welcome back to my channel. First, we will look at the problem statement, and then we are gonna approach it in a brute force way. Following it, we will find out what was the problem and then try to optimize it. After that, as usual, we will also do a dry run of the code so that you can visualize how all of this is actually working in action. Without further ado, let's get started. The problem statement is pretty straightforward. You are given an integer array and you have to find out the sum of only the unique elements. And how to define the uniqueness? Any element that appears exactly once in the array. Those elements are unique. So you just have to add them. And to understand it better, we can look at the sample test cases. For example, in a test case number 1, if you see, I have 1 and 3. These elements are appearing only once. The element 2 appears twice. So that is not unique. So what do you have to do? You have to return 1 plus 3 and that is a 4. So for the first test case, 4 is your answer. Similarly, if you now look at the second test case. In your second test case, all the elements are 1. So none of the elements are unique. Because unique means it occurs only once. So in your second test case, 0 will be your answer. Because there are no unique elements. Now, the third test case is also one of the edge cases. What do you have over here? You have 5 elements and all of them are unique. So what do? Just follow what the problem says. You have to add all the unique elements. Since all of them are unique, you will just add them. Adding all of them, you get 15 as the total, and then 15 will be your answer. So this is what the problem statement is, and these are considerably all of the edge cases that you might have to take care of. So now, if you feel that you have understood it even better, feel free to first try it out. Otherwise, let us dive into the solution. To understand things better, let us take up a bigger test case. And now you can see that I have all of these elements available. What is the first thing that comes to your mind? The first approach, or the brute force approach, or the most naive approach that you can think of is that, okay, I will start off with the first element, that is a 1. And I will iterate through my entire array to see, hey, can I find a 1? You traverse this array and you see that, hey, I am finding a 1 over here. So it is not unique. So you don't do anything about it. You will then move on to the next element and then once again try to iterate through your entire array. You do not find this element anywhere and hence this is unique. So what you will do is you will store this value. So far so good. Now look at the next value 3. Once again iterate through your array and you see that 3 is not present, 3 is unique. So you add this. Next go on to 4. You iterate through your array, 4 is present, so you will ignore it. Next comes 5. 5 is also unique, so you will add it. So similarly, you will keep on moving ahead and then you will add 7 as well. So this is one method to solve the problem. And in fact, this is the correct answer. But do you notice the problem with this approach? You are iterating your array again and again, right? Just to check, hey, is my element unique or not? So that ends up taking a lot of time. And as a programmer, you need to find efficient solutions. You need to find a way such that you can achieve the same result in a minimal amount of time. So how can you do that? Try to think like this. You are wasting a lot of time just to check if an element is present or not, right? So how about we store that information somewhere? If we can store this information and we can quickly see, hey, how many elements do I have? Then it will turn out to be very helpful, right? So what I do over here is I take the help of an array. And why do I take an array? Because an array has 2 pieces of information. One is the index itself and one is the actual value. So if I have an array like this, it will have all of these indexes like this. Now notice that when this array is initialized, all of these values are 0, correct? So to find an efficient solution, what you can do? You can start to traverse your array. When you start to traverse, you see that, okay, the first element is 1. Now, you can refer this exact element, what you will do is you will say ARR of 1, and this 1 will point to this location in your array. What you can do is you can say ARR at whatever this value is plus plus. So what this will do? Initially, your array is initialized with 0, right? So this will increment the value and I will store 1 over here. So basically, I have just stored that, okay, I found 1, 1 right now. Now move your pointer one step ahead. Now you are looking at element 2. You will refer to ARR at position 2. And this refers to this particular array position. Do a plus plus and it will change the value to 1 over here. So what is this array telling me? This array is telling me the frequency of each element up till this pointer. Now my next element is 3. So it will increment this particular value. Move ahead. The next element is 4. So this will increment this particular value. The next element is 5. So it will increment this particular value. Now move ahead and you will find something interesting. I am referring at ARR at 4, right? And where does ARR at 4 point to? ARR at 4 will point to this particular location. And what do? You increment its frequency. So when you do a ARR 4 plus plus, what will happen? This value will get increased by 1. So now this value becomes 2. So what just happened? In our frequency array, we are able to store the frequency of each element as we are encountering it. So now when you move ahead, you encounter a 1 again. So this now changes to 2. Move ahead, you get a 4 again. So you will increment the frequency. Move ahead one more time, you get a 4. So increment this. And now for the last element, you get a 7. So you will increment 1 over here. Now you have reached the very end. And check this frequency array. What is this telling me? It is telling me the frequency of each element. And what do you have to do? You have to find the sum of all the unique elements. Unique means that the frequency is 1. So as a final step, what I will do is I will iterate over this array, and if the frequency is 1, I just add up all of these elements. So I will get 2, then 3, then a 5, and then a 7. So you can see that just by doing a single iteration, I was able to determine the total sum of all the unique elements. And if you check the problem statement, you have one constraint. That is, all of these elements, they lie between the range of 0 to 100. That means the size of this frequency array can never be greater than 100. So that means a constant space. So the space complexity of this solution will be order of 1 or constant space. And the time complexity of this solution is order of n, because you will have to traverse through all the elements in the array at least once. Now, based upon this idea, let us quickly do a dry run of the code. On the left side of your screen, you have the complete code to implement this solution. And on the right, I have a sample test case that is passed in as an input parameter to the function sum of unique. Now, what is the first thing that we do? The first thing that we do is we create a frequency array to store all the frequencies. Notice that the size of my array is 101 because the elements can range from 1 all the way up to 100. So, although you can see that I have values only in the range of 1 to 7, this array will be large. It will start from 0 and it will go all the way up to 100. So, I have all of my indexes over here. Our array is now ready. The next part is updating the frequencies. So what I do is I start a for loop for each element in this array nums. And what will I do? I will pick up each number. So I pick up 1 and then I do frequency at num plus plus. So this will refer to frequency at num and this is gonna refer to this particular location. Currently every value is 0. So this will increment its value by 1. So over here, I will get a 1. Similarly, for the next iteration, over here, I will get a 1. Then for a 3, then for a 4, then for a 5, and then you see 4 again. So what will happen? For the 4, this value will in fact become 2. So this is the same idea and that is how we are implementing it. You are now done with all the frequencies. The last step is just finding all the unique elements and adding them up. So as a last step, Once again, I will run a for loop that starts from 0 and go all the way up till the end of this frequency array. And if this frequency is 1, I add this element to my sum over here. Once I am done iterating, this sum will now hold the total sum of all the unique elements, and then I will return it as the final answer. I hope I was able to simplify the problem and its solution for you. As you can see, there is nothing as such tricky about this problem. It is pretty straightforward. You just have to identify that, hey, this is the structure that I have to use. And your interviewer can play with the constraints. For example, in this problem, you could only have 100 different elements, correct? And that caused a constant space complexity because you cannot have more than 100 different elements. Your interviewer can say that, hey, the number of elements can be anything. There is no such defined range. Then the space complexity changes. You will now have to identify what structure to use. You can either keep using the frequency map or you can also use a hash map. That just depends on what is the input size you're expecting and what is the type of input. If there are a lot of different numbers, then yes, a frequency array is very good. But if there are only specific set of numbers, then you can go for a hash map. So just keep all of these things in mind when you're attacking this problem or approaching this problem in an actual interview. So while going throughout the video, did you face any problems? Or have you seen any other such problems which follow a similar technique? Tell me everything in the comment section below and I would love to discuss all of it with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I simplify programming for you. Also, a huge shout out to all the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments as well. Stay tuned for my next videos. Until then, see ya.